Sensors for robotics. Sound sensors. It's a generally a microphone used to detect the equivalent voltage of sound and return. It generates a minimal voltage difference. It should be amplified to produce a measurable change in voltage. The figure shows the sound sensor used in a robot. Proximity sensors. It's a transmitter transmits electromagnetic radiation in the adjacent sensor and receives and analyzes the interruption feedback signals. Best examples are IR trans receiver and ultrasound sensors. Proximity sensors used in robotics to find the objects. Tactile sensors. A tactile sensor is a device. It measures the coming information in response to the physical interaction with the environment. The sense of touch in humans is generally modeled, that is cutaneous sense and the kinesthetic sense. Tactile sensor is a device specifying an object contact. It is used to measure the applications of gently interact with the environment. It is sorted into two types, namely touch sensor and force sensor. The figure shows the tactile sensor. A touch sensor. A touch sensor is an electronic sensor used in detecting and recording physical touch. It is also known as tactile sensor. It's a small, simple, low-cost sensor made to replace old mechanical switches. It is capable of sensing and object touch. These sensors are commonly used in robots to avoid obstacles. Force sensors. It is used to calculate the forces of several functions such as loading and unloading, material handling, etc. The figure shows the force sensor used in robotics. Temperature sensor. It is used to detect the surrounding temperature change. It is based on the principle of voltage difference change for the temperature change. It includes air temperature, surface temperature, immersion temperature, various types of temperature sensors available, RTD, thermocouple, thermistor. So many temperatures are available for robotics. Navigation and positioning sensor. It is used to approximate the position of sensor. Commonly, positioning sensor is nothing but the GPS. Satellite orbiting our Earth transmits signal, and robot receiver acquires and processes these signals. Using the processed information, it determines the approximate position and velocity of the robot. The figure shows navigation and positioning sensor. Acceleration sensor. It is a device for measuring acceleration and tilt. Two types of forces will affect an accelerometer. They are static force and dynamic force. Static force, it's a frictional force between any two objects. By measuring the gravity, we can determine how much robot tilts. This measurement is useful in balancing robots. Dynamic force. It's an acceleration required to move an object. Measuring of dynamic force using an accelerometer determines the speed at which the robot moves. Robotics control. Open loop control of robotics. Desired response is given to controller. Controller output is directly given to parts of robot. This is called open loop control. In Next, closed loop control. In closed loop control, a feedback is there. It measures the position of output and compares with the desired position, and based on the error, controller gives the corrective action for actuator. Thank you.